Assalamualaikum and hi everyone. We are from Group 7 and we will present to you Chapter 7 which is Hydroxyl compound.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Imtiaz bin Abdul Jabbar. My metric number 9201002.
Assalamualaikum. My name is Daniel Hakim bin Taufiq Asmadi. My metric number is 9201009. Thank you.
My name is Nurul Awni Afifah binti Ahmad Azalidi and my metric number is 9200994 and I am from Group 7.
Assalamualaikum warahmatullahi wabarakatuh. I am Sa'idatul Najihah binti Azman with number metric 9200996 from Group 7.
Assalamualaikum. My name is Nadia Farhana binti Muhammad Zabdi and my matrix number is 9200975.
Okay, so let's move on to the inert component. Our group have been given functional group which is hydroxyl compound and we have chosen grapes plant as our chosen plant and we also have found the related Quranic verse in the Quran which is Surah An-Naba, ayah 32, Surah 78, which is Hada'iqa wa A'naba, and the meaning is garden, vineyard, or also known as grapes. I will tell you a little bit introduction of grapes. One of the active component in grapes is anthocyanin. The anthocyanin contains the hydroxyl functional group which is OH. The function of the anthocyanin is it can give a color and we can find the anthocyanin in the grape skin. Okay, for the composition and benefits of grapes plant, we will go to the composition of the plants first. Raw grapes are contain 81% water, 18% carbohydrate, 1% protein, and have negligible fat. 100 grams of different amount of raw grapes supply 288 kJ of food energy and a moderate amount of vitamin K with no other micronutrients in significant content. So, for the benefits of grapes plant, it packed with nutrients, especially vitamin C and K, and also high in antioxidant. Next, it also can prevent chronic diseases. Plant compound can protect against certain type of cancer and also help to decrease blood sugar level. Then, grapes plant can protect against diabetes and improve memory, attention, and our mood. Furthermore, grape also can protect us against certain bacteria, viruses, and yeast infection. Lastly, it can also slow down aging and longevity.
Question is we need to draw the skeletal structure of 3-methyl-1-butanol. Firstly, we identify the parent structure which is butanol consists of 4 carbon. Then we draw the 4 carbon skeletal in zigzag line. The hydroxyl group is attached at the first carbon. The first carbon and 1 carbon branch is which is methyl is attached at third carbon to form 3-methyl-1-butanol. Next, the EQN for the formation of the ester and the IUPAC name of ester form. When 3-methyl-1-butanol reacts with ethanol chloride, isopentyl ethanoate is formed, and the observation of this reaction is sweet fruity small, which is the ester.
Okay. For the next question, it shows a equation here or a reaction to form whether 3-methyl-1-butanol is heated to form P and is mixed with the acid to form Q and mixed with excess NH3 ETOH reflux to form R. So, based on the reaction scheme above, state the type of reaction occur for the formation of P, Q, and R. draw the structure and state the IUPAC name of P, Q, and R. So here, we need to do three things. First, state the type of reaction occur. Next, draw the structure. And lastly, state the IUPAC name of P, Q, and R. So, it start with 3-methyl 1-butanol. So I think you know how to make the structure of 3-methyl 1-butanol, which is this CH3O3 CH2OH and single bond here CH3. It is still a bit messy, but you know this. So this is 3-methyl 1-butanol here. It is starting for the formation of P, Q, and R. So here the answer for P, Q, and R. So for the P reaction or for P formation, the reaction occur is elimination of alcohol by using the concentrated H2SO4 or sulfuric acid. So the 3-methyl 1-butanol here at the beginning is mixed with the concentrated sulfuric acid to form a new compound, which is P compound. The CH3C double bond, CH2CH3, and here single bond CH3 plus H2O, because we need to because this is a elimination of alcohol, so it will produce water. The name of this compound is 2-methyl butuin. That is a scheme name, but if you know how to pronounce it in our name, then silakan. Next, for the Q formation, or for the formation of Q, the type of reaction occur in Q is electrophilic addition of alkenes, which we take the P, we take the P compound earlier and put it here, because as at the question we saw that after P it will react with hydrochloric acid to form other compound. So put it in here, and just at the question react with hydrochloric acid to form the Q compound, which is this CH3 CCH2 CH3 single bond Cl and single bond CH3. As for the name of this compound Q, it is 2-chloro 2-methyl butane. 2 2-chloro 2-methylbutane. Okay, next. As for the formation of R, the type of reaction occur is nucleophilic substitution of alkyl halides. Alkyl halides. So, as the previous one, we take this answer, we take Q compound, put it back here, or that here, to react with the excessive NH3 and ETOH reflux, and to form the R compound. The NH2, the CH3, CCH2, CH3, single bond NH2, single bond CH3. As for the name of the compound is 2-methylbutan 2-aminate. So, that's all for this question. Thank you.
So I'm going to continue. Okay, so the question here is show the reaction mechanism for the formation of P. So as can see here, this is elimination process. So elimination reaction mechanism process involves 3 steps, which is step 1 is protonation of alcohol, step 2 is elimination of H2O to form carbocation, and step 3 is removing of an H plus. So, but note here is alkyl group and hydrogen can migrate in reaction to give more stable intermediate carbocation. So, we're going to go with our answer here. So first, initial process of step 1, protonation of alcohol. So as we see here, this is 3-methyl 1-butanol. We can see OH here, CH3 as a methyl group. So OH is a not good living group. So it needs to be protonate to form a OH2 plus. So as we it's gonna be migrate to H plus and to be a OH2 plus. So it's the bond is going from the O, not from the H. It's going from O to H. Okay. So step 2, elimination of H2O to form carbocation. So as we can see here, it's still methyl 1-butanol, but it already been OH2 plus. So OH2 plus here is going to the arrow is going to from the bone, okay, not from the carbon here. It's going from the bone, and the rate of the reaction is going to be slow. So we are going to eliminate of H2O here. So we're going to take it out of OH2 plus here. Sorry, there's gonna be a OH2 too. Okay, so the reaction of slow. The reaction is slow. So it gonna when we take out the OH2 plus, it's gonna be like this. There will no bond that continue from the C carbon here at the beginning, and it will be plus H2O here. So we already eliminate H2O from the bonding here. So it should be a 3-step only, but as I said just now, that alkyl group and hydrogen can migrate in rearrangement. So the step 3 is a rearrangement between 1, 2 H shift. So we're gonna shift the H here, the H hydrogen here. So first step, we're gonna take H to arrange it from the carbon 2 to the carbon 1. So it's gonna be 1, 2 here. So it's gonna be here, as you can see the plus sign here. So it's gonna be 1, 2 H shift. So the H bonding at the carbon 2 will um, be at carbon number Y. Okay, so we already shift it to give a more stable intermediate carbocation. Okay, so for step 4 is a removal of H plus. So as we can see here, at the carbon number 2 is there are no bonding. There are so we cannot let it like this because it's not complete yet. So what we can do is, okay, so the last step is the removal of H plus. So we're gonna take the H plus at the carbon number 2, take it from the bone here. We're gonna make it become a alkene. So alkene is a double bond. So when we remove H plus to become the bone here to the bone number 2, so it becomes like this, double bone here, it become alkene, which is 2 methyl butene. So this is the last answer for the reaction mechanism for the formation of P. So and don't forget the H plus that we already remove is gonna be at the beside it a plus H plus, because we already remove it to become a double bond here at the number 2, so it becomes 2 methyl butene because it alkene is the bone the number 2. Thank you.
Okay, the question for this slide is show the minor product that can be produced when 3-methyl-1-butanol is heated with concentrated sulfuric acid. When 3-methyl-butanol is heated with concentrated H2SO4, then it should produce alkene and water. So, based on this slide, we will get 3-methyl-but-1-ene as the product. But as we all know, this reaction can produce two products, which is a major and a minor one. So for the major product, it has been told in the previous slide. So I will tell you about the minor product for this reaction. So as we can see on the slide, 3-methyl-but-1-ene is the minor product for this reaction. Because compared to 2-methyl-but-2-ene, which is a major product for this reaction. This is because 3-methyl-but-1-ene has less alkyl group compared to 2-methyl-but-2-ene. So it become a minor product while the other one become the major product. So that's all from me. Thank you.